Okay, welcome. Today I'm doing a demo for the basic features of winEEG, and let's get started. So, um, when you open up winEEG, it's going to look like this, and actually they've included some example data in the installation folder. You can download it by going to the MITSAR website and requesting a download link. This is version 3.8.21 that I'm running right now. So to open that example data, it's in winEEG examples. And I'm going to pick this bottom one right here. And the free version of winEEG will open any files that were recorded with MITSAR amplifier, and I believe also BMEDIC amplifier that end in .eeg. So here we go. This is what the EEG looks like. This is really intended for people who have some experience looking at EEG, so I'm not going to explain like the super basics here, but we have our lines of raw data going across the screen, and the different channels are labeled on the left here, and the time in seconds is labeled along the top. So we have 1 second between the dark lines and 1/5 of a second between the smaller lines. And generally, we have the frontal sites up at the top and the posterior sites at the bottom. This is also labeling the montage here. AVW stands for average weighted. So the first thing we might want to do is change our montage. There's a bunch of montage options in this software. That's one of the things that I like about it. And you can change your montage either by going to Setup Montage List or clicking on this button over here, Change Montage. If we click on the button itself, it will show us the montage that we have currently selected. Looks like this one is called Database. And the montages are all adjustable, and you can save them with their own names, and so they're totally, customizable. But without getting too into the weeds, we're just going to change this to an average reference montage. This one is actually my favorite, the database version 2. This is basically like a global Laplacian average. And the other thing I want to do is get rid of this ECG channel at the bottom because it looks like they weren't actually using it and it's just kind of hanging out there for no reason. So we're going to deselect that, click OK. So now we're set up in a reasonable montage, and the next thing I like to do is to apply filters. By default, these are the filters. This is what they used to record the HBI database. Oftentimes, I will apply a more aggressive low-cut filter, something like 1.6 here. And if there's a lot of line noise, it might be necessary to use a wider notch filter, or if you're here in the US, do 55 to 65 instead of 45 to 55. So you just saw me change the gain of the screen, and that's done by using the scroll wheel. And I like to have that set up just so things aren't really touching each other. And you can see we have eye blink here. So I'm just going to briefly scroll through, not get into any sort of clinical interpretation of the data, but just generally viewing what's happening in this file. It looks like it's not too long of a file. Here we are a minute in, and we're already basically almost a quarter of the way through the file here. So it's not a crazy long recording, and it says eyes opened here. That's actually the fragment that we're in. So you can see at the beginning of the recording, the eyes open section starts, and I'm going to guess that there's an eyes closed fragment that starts maybe about halfway through. And yeah, there we go. So you'll see when the eyes closed fragment begins, I guess that this is the time that it was recorded at. And then this second counter here restarts. And we can see some nice posterior alpha showing up in the EEG. So Just going to scroll through, take a quick peek at what's happening. Obviously, there's some brainwave activity, some slow wave activity in here, and some eye movement artifact. And if I were really interpreting this, trying to get some meaning out of this, obviously I would take longer in this initial scroll through, but I've already seen this data, and I don't want to make this demo too long. The main thing I want to do actually is show what it is that I find so useful about winEEG. I already showed how you do the filters and the montage, but my favorite feature of winEEG is the ICA artifact correction. And I'll do a longer video on this, and just so you know what I'm doing, I right-clicked at the end of the file in order to create a selection, and I'm going to left-click at the beginning. That's how you make selections of data in winEEG. You left-click on the left bounds and right-click on the right bounds. So my favorite feature of winEEG is that button right there, the artifacts correction feature. And actually, you can also do it by going to Analysis, Artifacts Correction. And this uses independent component analysis, which are a group of machine learning algorithms that help identify spatially and temporally independent features within a multidimensional data set like EEG. So without getting too much into the theory, this is basically trying to use matrix math to identify things which are independent from each other. And you'll notice over here that we have topographies. And so you might be thinking, well, hey, why do we have topographies over here when we already know that each one of these channels corresponds with a specific sensor on the scalp? And that would be a good question. These are actually two sort of like separate parts of this window. So these three bins right here, each of these lines corresponds to one of these channels over here. So FP1, FP2, etc. In this portion of the screen, these are components which have these spatial distributions. So we're no longer looking at channels. The numbers here actually reflect the variance, or the sort of measure of statistical independence of sorts from the other parts of the data. So that's a little bit of what's non-intuitive about this. But what this allows us to do is pull out artifacts without having to just snip out whole sections of the data. And so this first component is an eye blink. The eye blink topography looks like that. And you can see we've now excluded this artifact from the raw EEG. And when we click OK, the data is going to look like this, which is fantastic. We've gotten rid of this eye blink. And most importantly, we've also not really removed any real EEG activity from the record, which you always want to be very careful of when you're doing ICA artifact rejection. So I'm not going to get super deep into this process. Thankfully, it's a pretty clean record. There's probably a lot lateral eye movement that we could try to get out. But I just want to show you in broad brush strokes what this does. So you find a topography over here that you think might be noise, and you can also try to identify it based on what the waveform looks like. You select it, you vet it by looking at the excluded artifacts and corrected EEG to make sure that you're not pulling out real activity. And so long as it's just artifactual data, such as eye blink or muscle tension or line noise or whatever, you select it by having it have the red circle around here, and then you click OK when you're done. Now, I've just scrolled to a section where it looks like this could be pulling out the lateral eye movement. You see F7 and F8 just had their phase inverted eye movement activity removed by clicking on this component. Before I proceed, I I just want to double check that doing that didn't remove real EEG. So I'm actually going to scroll forward to the eyes closed section. And it looks like that's a pretty solid component. Anyways, there's more to get into here, but that's a very basic job and probably a satisfactory one. So now the data look cleaner. We have no eye blink in here, and we've taken out at least some of the lateral eye movement. So now if we wanted to clip out certain sections of the data manually, we could do that. So if we want to exclude this from when we do the spectral analysis, we would left click up there, right click over here. You can do Control X, or you can click this button right here, the cut button. We can also tell the computer to do this automatically by going to Mark Artifacts, and you can set these thresholds. I'll probably do a separate video on how to set these thresholds appropriately, but the basic idea is that we'll just choose anything that goes above those thresholds. And it looks like we set those too low, so we'll try again. Here, let's put 70, oopsie, 70. 30 microvolts for low frequency, and let's say 12 for high frequency. And let's see if we caught anything with that. Wow, nothing. Really? Let's try 50. Okay. Strange. Well, now it's capturing this. I feel like something must be awry here. What if we do 30? Okay, now it's picking up more stuff. Anyways, I'm going to remove those because there's not a lot of stuff that I'd want to exclude from the spectra. So let's now look at the time frequency analysis, and we can do that by going to Analysis and EEG Spectra. So when you do this, you can either select a selection, which we didn't create, but if we wanted a selection, we could go like that. But we're going to do the whole eyes open fragment. I'm going to click, I tend to keep these the way they are, these settings. Click OK. And now we can see a time frequency analysis of the data. So basically what we've done is we've removed the time domain. We've taken the average over the course of the whole recording, or rather over the course of the whole eyes open fragment of each of these frequency bins. So, and the x-axis scale is the same for all of the channels. We have 10 hertz here in the middle of this yellow portion, 20, 30 hertz is sort of the top of the bounds. And on the y-axis we have power, and actually you can change it to amplitude if you want to. Power obviously is microvolts squared, so you come up with a little bit of a different distribution. And the topography here is what it's like on the head. So CZ is the top in the middle of the head. This is next to the left ear, next to the right ear. This is above the eyes. This is the back of the head. So this is showing us the frequency content, and if you click, it will tell you down here in the bottom right what the frequency of that is. So this is 5.37 hertz. If you want to create a topographical map of that frequency, you can right-click and click Add Map, and then down below we now have a map of 5.62 hertz, where it's 0.9 microvolts squared at CZ, and then sort of drops off everywhere around that. So let's make a couple more of those. Here, let's pick out this alpha feature at CZ. You can see similar distribution, much lower power than this theta feature. And then look at that, the back of the head, the alpha is faster. We have an 11.47 alpha that has a maximum power of around, 0.5, or in this case 0.467 microvolts squared. So make sure you note the units here. They're going to be different for each of these topographies that you create. We have another alpha peak, a faster sort of left posterior temporal. So anyways, this is kind of cool. You can create maps of the different frequencies. Looks like there's some beta activity at CZ. And you can also look at coherences. So I like to look at the average EEG coherence. This will do a comparison to one of the channels, but the average, we'll look at the average coherence. And, alpha coherence is starting to get kind of high here. And this is obviously just surface coherence. So anyways, that's about it for this video of just some of the basic features of winEEG. Thanks for watching. I have some more demos coming up. Let me know what you would like to see more of, and enjoy.